we've been brought in to look at the embodied carbon, and I suppose the key point here is that, as Doug mentioned, they've already got scopes 1 and 2 fully covered, but they've also got some of scope 3, and what we're looking at is the sort of the elephant in the room, or on the runway, whatever you want to say, which is the embodied carbon, which is not just on an individual building basis, but as an overall strategy. First, just say a quick word about us. We cover carbon analysis and carbon advice at all those levels: policy, master planning, buildings, and through to people. And we advise all those sorts of people, and we also advise those sort of clients. So we've got quite a spread of people we talk to. So environmental mapping, embodied carbon, and the circular economy. So what this is all based in is the British standard, which comes from a European directive, which is BSEN 15978, and that sets out how carbon emissions reporting. And in fact, at an earlier talk, I was explaining how the RICS is producing a professional statement, which we are writing to bring this into mainstream in the UK in a much more clear fashion. But just in quick summary, so this is covering the product stage, the selection of materials, and fabrication of components. Then you've got the construction stage, and then which takes you up to practical completion. And then you've got, from then on, you've got the in-use stage, which is the repair, maintenance, replacement, and so on. But you've also got operational energy. So that's the recycling element, and this is B6, which is operational. So this covers all the carbon emissions through the built environment aspect. So it's not covering takeoffs and landings and things like that, or transport to and from the airport. So you've got, as I said, you've got product stage, construction stage, you've got the in-use stage, and the end of life stage, which is deconstruction, transport, waste processing, and disposal. And as you would have heard from Doug, a lot of the projects involve all of these stages on a continuing basis. And indeed, this bit, the reuse recycle, is what we're hoping we can help bring in, so that new things are not necessarily wasted. And of course, that is what is the circular economy, is reuse, recycling, and so on. Carbon management plan. What we've done is we've created a GIS map, and this map here is every single polygon, each little piece of this is represented behind it with a spreadsheet. So that, for those of you aren't familiar, that's what a GIS map is. So there's actually a vast amount of data hidden inside that map. In fact, the map is effectively a spreadsheet of sorts with extra spreadsheets behind it. And what are we trying to do? So what we're trying to do is, with the GIS mapping, is to embed circularity and get low carbon outcomes. So we've done a base inventory of all the existing assets, and of course some of those, like grass areas or trees and what have you, will actually be a positive thing as opposed to, if you like, an embodied carbon cost. And then we've done operational maintenance. So that's the next phase, is looking at the operation and maintenance of the airport and how that relates to the first bit. Then then the idea is to overlay that with the new projects, the capital investment projects that Doug referred to. You can see there's a layering of information here. We've got existing operations and maintenance, and then new projects is the next layer of information that would come up. And the idea is to manage redundant or reusable resources. So as things are demolished or need to be demolished, we can plan in advance what might happen to those in terms of do they have a value elsewhere on the airport, or indeed do they have a value elsewhere outside of the airport. And the idea also is to design for future circularity and resource efficiency. So what we're doing is working with, or starting to work with some of the project teams to build in the idea that whatever they're building today may need to adapt and change for the future. So rather than that becoming a complete reinvention or an inefficient process, is to improve the resource efficiency of that kind of process. And ultimately what we're trying to do is get an improved carbon and resource trajectory, and ultimately, as well as part of all this, is to reduce costs over time. So the idea is to create an evolving environment of the way things are done, which is fully understanding what is above and below ground at Gatwick. So how does this work? Now, for those of you not familiar with what a GIS map is, as I said, each of these, whatever this is represented by a data sheet behind that. So in this case, we've got Jubilee House, which is an office building, and behind that we've got a whole lot of data. And this will be data, product data, there'll be information about the structure, the cladding, and the data we've got on this is really data that we're interested in from a carbon perspective. So we've collected all that data, and of course we've collected data from all the other things around the airport as well. So for example, this is an area of green material, trees and things, and we've got data on that as well. But we've also got things on car parks, anything here is covered. And of course we can cross-reference all that data, and that's the key point. This is a sort of an additive thing where this is, if you like, a carbon intensity map, and this bit here represents the sort of greatest intensity of embodied carbon, the material that have taken the aggregate value of the material here in terms of embodied carbon is the highest, and as it goes down, the grey is actually paradoxically the green areas, but it's the grass, trees, ponds. And interestingly, Gatwick, the amount of built area and the amount of green area at Gatwick is about the same. So it's about 50-50 green. And to give you an example of one of the kind of studies we've done. So this is all the sort of hard surface. This is a hard surface analysis. And what we've done is highlight each of these. And we've got behind them, in our data sheets, we've got the build-ups of each of those hard surfaces. So this represents all of the hard surfaces, and it represents all the different build-ups. And of course, those build-ups have been developed over time, and new technologies come along and replaced and so on. So there's an evolution here. But what is interesting is that in practice, there's only about 4 or 5, and Doug may contradict me here, but about 4 or 5 basic surface types from runways through to roads. And of course, we've got quite a lot of different build-ups behind them. And the question is, can we, over time, make that more efficient? And by overlaying that with the areas of each of these, we can see where the hotspots are that we should be focusing on in terms of long-term thinking in this area. So then if you're looking at, say, a capital investment program, and let's say we're looking, for argument's sake, at a new building here, one of the things we'll be interested in is what have we already got here? And we've got these 2 piers, which this one is, I think, up for refurbishment or just being refurbished. This one would have to be demolished. And the question then is, can it be used somewhere else? Now, this link block here, in fact, is a modular construction steel frame. So on the face of it, with pre-thinking, if something similar is required somewhere else, there's no reason why we couldn't arguably reuse that. And the idea would be that although this might not be super efficient today, over time, this kind of approach of making things more modular and in a reusable sense would become more efficient. And so that's the site of that potential thing, and those are the link blocks. But so this is a question of looking at material from around, in terms of reuse, as I said, the material that's already in these buildings. When it comes to redeveloping this particular bit, can any of that be used anywhere else? But equally, can the building that is to be proposed on this site, is there anything that is from other redevelopment opportunities around Gatwick, can any of that be brought in? So in other words, it is rethinking how we put this all together with the possibility of moving material around. And we've done this on individual buildings, particularly warehouse type buildings or warehouse and office combinations, where we have actually dismantled and moved entire buildings. And it is cost effective, it's carbon efficient, and you reuse most of the material. So as an idea, it has potential. It's really a question of how that evolves and can we bring down the costs of running this over time. What we're looking to do, therefore, is the key impacts is to identify the impact on existing built fabric by making changes, identify the existing fabric for potential reuse, and identifying waste in advance. So when you draw a line around a potential redevelopment or redevelopment site, it's what below and above ground are we looking at and targeting to make a more efficient series of decisions, particularly with regards to waste, and not compromising those things that we have there that we don't want to damage. It's also identifying fabric from elsewhere, optimizing resource management, and reducing costs. And I suppose the key outputs overall are overall resource management right across the site. So it's existing material, it's new material, and it's tying in with maintenance and operational, and then integration with other emission sources. So it's and avoiding unintended consequences. The idea is to get a complete picture of all the emission sources across Gatwick from all aspects, and to integrate them and overlay them, and ultimately that will bring in potentially things like what the transport in and around the site, to the site, and for that matter what passengers are doing, consumables and so on. Unfortunately I can't give you the last slide, which is a plug for a book that I've got coming out. Oh, there it is, Targeting Zero, which there is this case study about Gatwick in there, and other infrastructure stuff, but it's published by the RIBA Publishing, and it's called Embodied in Whole Life Carbon Explained. But to summarize, I think what we're trying to do with Gatwick, and I think is move them, as I said, into a greater spread of the Scope 3 emissions. And I think it'll, to my knowledge, we've had a look quite closely at other airports in the UK and Europe. This will put Gatwick ahead of, I think, most of the competition. So thank you very much.